Hey everybody, it's time for some science. So we've been talking a lot lately about acceleration, observing things accelerating and describing the motion of those objects through velocity over time graphs, then using those to make predictions about the way that they're moving. What I'd like to do now is discuss some hard numbers with acceleration. Really get into how we can figure out how fast something is accelerating and in which way. To that end, I've decided to bring back something that you've probably seen recently to help us parse out how we're going to do that. Welcome back to Accelerating to Awesome, the concept builder that you guys have looked at earlier this week. Today, I'm going to look at this section, adding value to acceleration. We're going to look at some scenarios in which things are accelerating and try to calculate how much they are accelerating in each one. So let's get started. Now pay close attention because for this video I am going to jump back and forth a little bit between the concept builder and another page that's just going to help me write some things down. But let's take a look at this first problem that we got right here. It's got a car moving rightward, shown with the time at 0 seconds, moving all the way to 3 seconds. So this is a 3-second interval in which they started at 3 meters per second, shown here, and they sped up to 12 meters a second. And we are just trying to figure out what the magnitude and the direction of acceleration are. Well, let's talk about direction first, because I feel that that's a quick one to answer. We're moving to the right, which is our positive direction, although this is just going to ask us left or right. And it seems that we start off at 3 and move to 12. That means we're speeding up. So if we are moving rightward and we're getting faster, that means that our acceleration is in the same direction as our movement. And so we're also accelerating in the rightward direction. So right is what we're going to put there. When it comes to magnitude, follow me really quick and we'll work it out with these numbers. Okay, so I've written it out here in a place where I can write just so we can have a visual. Now, we're trying to figure out basically how much faster he went every second. So to figure that out, let's figure out what our total change in velocity was, how much he changed over the course of these 3 seconds. We went from 3 to 12, so 12 minus 3, 12 minus 3, and I'm sure a lot of you guys can do this in your head, and that's fine. You can just do it up here in your brain. 12 minus 3, that's 9. So we have a total difference of 9 meters per second. And if that's the case, and we did that over 3 seconds, so 9 meters a second in 3 seconds, how much did we change in 1 second? Well, that's easy. All I have to do is, well, if 9 meters a second in 3 seconds, then I can divide by 3 seconds. And that'll tell me how far I go each second. The answer to that is 3. So in short, if I speed up 9 meters a second in 3 seconds, then I speed up by 3 meters a second every second. All right, so I typed that in here. Let's see how it goes. Yay! All right, let's go to the next one. A westward moving motorcycle increases its speed from 5 meters a second to 25 meters a second in 2.5 seconds. So again, the first thing that we need to do is figure out how much did he actually change his velocity total. Okay, well that's just 25 minus 5, which is 20. Okay, and I want to know if he changed his velocity by 20 meters a second in 2.5 seconds, then how much did it change every second? So again, I'll just divide 20 divided by 2.5. Let me go work that math out real quick. 8 meters a second. So that is our magnitude. Now let's talk about direction. So if he's moving west and his speed is increasing, that means his acceleration is in the same direction as his velocity. So it should be west. All right, let's do it again. Oh, this one's got a table. So velocity time, the velocity time table represents the motion of a leftward moving car. What is the magnitude and direction of the acceleration? Well, let's see. His velocity at time 0 is 20. At time 1, it goes down to 16, which is 4 less meters per second. And then he moves down to 12, which is 4 less again. Then 8, that's subtracting another 4 from it. And then 8 and 4, well, that's subtracting another 4 from it. So it seems like his velocity goes down by 4 meters a second every second. So we already know our magnitude is going to be 4 meters a second every second. When it comes to our direction, well, it's a leftward moving car, but it's slowing down as it moves left, so our acceleration is in the opposite direction, so it's to the right. Oh, it's another car one. So, velocity and time information for a leftward moving car are shown. All right, so we're at the left, so we start over here at time 0, and we're going 16 meters a second. And then we move to the left, slowing down to 4 meters a second over 4 seconds. All right, let's take a look at this one. Okay, well, very quickly, we already know that our change in velocity, which I'm going to show with this little triangle here, that little triangle is going to mean change. I already know that it's just whatever 16 minus 4 is, which is 12. So we've changed 12 meters a second in 4 seconds. Well, if we did that in 4 seconds, how much did we change every second? Let's look at a table to help us out. So if we already knew that there was a change of 12 meters a second, and it's going to happen for 4 seconds, then I can still just divide. And what I'll end up with is 3 meters per second. But here's what I'm going to do. I'm going to use this table to kind of check that answer. Basically, if we're slowing down 3 meters a second every second, then we should wind up going from 16 to 4 in 4 seconds by subtracting each time. By subtracting 3 each time. So 16 minus 3, that's 13. And then 13 minus 3 is 10. And then 10 minus 3 is 7. And then 7 minus 3 is 4. So it looks like we've got it. And thanks to the table, we were able to check our answer. If we're moving to the left and we're slowing down, then our acceleration has to be going the other way, to the right. Yay! Oh, look, another table! So this one represents a rightward moving motorcycle. So what is the magnitude and direction of acceleration here? Well, it looks like the table has the times set out in every half of a second. So what I can do here is when I go to the velocity, I can look at the changes that are made, not just going from one row to the next, but going every 2 rows, so that I know how much it's changed every second. So we go from time 0 is at 24 to time 1 is at 16. And then from time 1 at 16, we go down to time 2 and we're at 8. It would seem that we're going down by 8 every second. So that's going to be our magnitude. We're changing by 8 meters a second each second. And in terms of direction, we're going to, well, let's see, we have a rightward moving motorcycle, and we're slowing down because our velocity is getting lower. So that means our acceleration has to be opposed to our velocity, it has to be to the left. Boom, we got it. All right, let's take a look at the next one. let's see, a westward moving bicycle slows down from 10 meters a second to 4 meters a second in 3 seconds. What is the magnitude of acceleration? Well, we know that we've gone from 10 to 4. That's 6 meters per second. And check this out. This time, we're going to try to do it in our heads. If we changed 6 meters a second in 3 seconds, then every second we must have changed by 2. How did I know that? Well, if we've got a change of 6 meters a second and we do that in 3, well, 2, 4, 6. Look at that! We've got 3 intervals in which the speed has changed. So 2 meters a second is our answer. And then in terms of direction, well, it's westward moving and it's slowing down. So again, it's going to be opposed to us. It's to the east. Hooray! We did it! We're now wizards at acceleration. Thank you so much for your participation in that today. Alright guys, I hope this video was helpful. I hope that it made acceleration more valuable for you. If you have any questions, feel free to send a comment to me on the assignment. Thank you very much. Have a great day.